trying to keep up with all these new regulations, it can feel a bit like you're learning a whole new language, especially when it comes to something as complex and rapidly changing as artificial intelligence.
It really is a constantly evolving landscape. Keeping pace can be challenging, even just figuring out what fits where, definitionally.
Exactly. And that's precisely why we're here today. Think of this deep dive as your guide through the dense forest of legal documents. We're zeroing in on a specific one, the European Commission's guidelines on the definition of AI system. We're extracting the essential insights so you don't have to wade through all the jargon.
It's really key, this definition, because the AI Act, that's the EU law, regulation EU 2024-16889, for those taking notes well, it only applies to tech that actually qualifies as an AI system, according to these guidelines. The Act took effect last August, by the way, but this definition specifically kicked in just this February. So understanding this is really the foundation for everything else.
And it's not like these guidelines just appeared out of nowhere. The European Commission put in a lot of effort, gathering feedback from a whole range of stakeholders, incorporating input from the European Artificial Intelligence Board. There's a lot of thought behind them.
True. However, it's important to note that these guidelines themselves aren't legally binding. Only the Court of Justice of the European Union can give us the ultimate authoritative interpretation of the AI Act. But these guidelines are still super valuable. They act as a guide for providers and, well, anyone involved in developing or using AI systems, helping them see what falls within the scope of the AI Act.
All right, so our mission today is clear-cut. We're unpacking the 7 core elements that make up the EU's definition of an AI system. By the end, you'll confidently know what's considered AI and what isn't. Ready to explore these elements in detail?
Absolutely. Let's get started.
Great. So first up is the concept of a machine-based system. Sounds pretty straightforward, but what does it actually mean in the context of AI?
Essentially, it means that the system is developed and operates using, well, machines. And that includes both the physical hardware, think processors, memory, all that, and the software side, the code, the algorithms, the operating systems.
So it's really all about computation happening on machines.
Exactly. And the guidelines are clear. Almost all AI systems today are machine-based. It's the only way to handle the massive computational demands of things like training huge AI models or making those complex real-time decisions.
What's fascinating is that the guidelines don't stop there. They even consider some truly futuristic possibilities.
Yeah, they go as far as to mention systems like quantum computers. Even though they work on completely different principles than our everyday computers, they still fall under this machine-based umbrella because fundamentally they're still performing computations. And get this, they even touch on the possibility of including biological or organic systems if they ever reach a point of having similar computational abilities.
Wow, that's pretty mind-blowing. So right from the first element, we see that this definition is really encompassing, focusing on the underlying machinery that powers the system.
Absolutely. It sets the stage for the more detailed characteristics that really pinpoint what makes an AI system an AI system. And that brings us to our second element, being designed to operate with varying levels of autonomy.
Varying levels of autonomy. Okay, this one needs some unpacking. What exactly do we mean by autonomy in this context? And what does it mean to have varying levels of it?
Good questions. Let's turn to Recital 12 of the AI Act for some guidance. It states that varying levels of autonomy means systems are designed to operate with, and I'm quoting here, some degree of independence of actions from human involvement and of capabilities to operate without human intervention.
So we're not talking about like fully self-aware robots making their own moral judgment, right?
Not quite. The key phrase there is some degree. The definition explicitly excludes systems that function solely through direct, manual human input. But even if there's some kind of indirect human oversight, maybe automated monitoring or control mechanisms, that still counts as a degree of autonomy. Humans might set the initial parameters or supervise things, but the system itself can act with a certain level of independence.
Do you have an example to help illustrate that?
Sure. Imagine a software tool where you input some basic data. Then the software processes it and creates a full report, all without you having to lift a finger. That shows some degree of independence. Or think about expert systems used in specialized fields. A human expert sends it up with knowledge and rules, but then the system can analyze new cases on its own and offer recommendations. That's an example of varying levels of autonomy in action.
So I'm starting to see the picture. So it's about the system's ability to interact with its environment or data with some self-direction. It doesn't have to be constantly guided by a human, and it's not tied to any specific technology like machine learning.
Precisely. The focus is on that inherent ability to function with some level of independence. And as we'll see later, the level of autonomy is important when we consider the potential risks of a system and the need for human oversight.
Got it. Onward to element number 3. The system may exhibit adaptiveness after deployment. That word may seems very intentional.
It definitely is. Adaptiveness, as Recital 12 explains, means the system has self-learning capabilities that allow its behavior to change after it's been put into use. So over time, the same input might lead to different outputs as the system learns from new data or experiences. It's not just about what the system can do now, but what it might be able to do in the future as it learns.
So it's like a system that can actually get better or change its approach based on new information it encounters in the real world.
Exactly. But as you pointed out, that word may is crucial. It's a possibility, not a requirement. The guidelines state that a system doesn't have to be adaptive to be considered AI. The potential for self-learning after deployment is enough.
That's a really important distinction. So even a system that doesn't change its behavior after implementation could still be considered AI if it meets the other criteria.
Exactly. Adaptability is a potential characteristic included in the definition, but not a mandatory one for every AI system.
All right, let's move on to element number 4, and that for explicit or implicit objectives. This seems to imply that AI systems are inherently goal-oriented.
You got it. All AI systems are designed with certain objectives in mind. And as the guidelines explain, these objectives can be either explicitly programmed or implicitly derived.
Can you break down the difference between explicit and implicit objectives?
Sure. Explicit objectives are the goals that the developers directly program into the system. Think minimizing a specific error rate, getting users to interact with a service, or hitting a certain level of accuracy in predictions. These are the intended outcomes that are deliberately built into the system's logic. Implicit objectives, on the other hand, aren't directly written in the code. They're more like goals that we can infer from the system's behavior or the data it was trained on. Let's say we have a recommendation system. An explicit objective might be recommend products the user is likely to buy. But an implicit objective that might emerge is get the user to spend more money, even if that's not directly programmed. It's about the difference between the goals we intend and the outcomes that emerge from how the system interacts with its environment.
That's a really clear way to put it. The internal objectives are the how the system operates, while the intended purpose is the why.
Exactly. And the guidelines emphasize that the intended purpose, as defined in Article 3 of the Act, is all about how the provider wants the system to be used.
Got it. So the internal goals are about how it works, and the intended purpose is about how it's used in the real world. Okay, now we come to a core part. Element number 5, the system infers from the input it receives how to generate outputs. The guidelines really emphasize this capability to infer.
Absolutely. Recital 12 actually calls it key and indispensable. It's what separates AI systems from simpler software. It's not just about blindly following predefined rules. Inference is fundamental to AI, how it thinks and learns.
And it looks like inference encompasses both what happens when the system is being used and the process of developing it, right?
Yes, you're right. The guidelines say that inference covers generating outputs, things like predictions, content, recommendations, decisions during the use phase, but it also covers the process of creating the models or algorithms from data during the building phase. It's about how the system figures out how to produce those outputs, both in real time and during its initial creation.
And this is where they start talking about AI techniques, like machine learning and logic-based approaches.
Exactly. Recital 12 specifically mentions machine learning approaches that learn from data how to achieve certain objectives and logic and knowledge-based approaches that infer from encoded knowledge to solve tasks. These are the fundamental methods that allow AI systems to infer.
Let's dive into some examples, starting with machine learning. It seems like everyone is talking about machine learning these days. What specific types does the guideline mention?
They cover quite a few. For supervised learning, where the system learns from data that's been labeled, they give examples like spam filtering, image recognition, classifying photos, medical diagnostics, and fraud detection. Then there's unsupervised learning, where the data isn't labeled. There, they talk about AI being used in drug discovery to find patterns in chemical compounds.
And there's also self-supervised learning, right? That's sort of a hybrid approach.
Yes, exactly. Self-supervised learning is a type of unsupervised learning, where the system kind of creates its own labels from unlabeled data to help it learn. Some examples include image recognition systems predicting missing parts of an image, language models predicting the next word in a sentence, and speech recognition systems. Then, of course, we have reinforcement learning, where the AI learns through trial and error based on rewards and penalties. Like training a dog with treats. The dog learns which actions lead to a reward, just like a reinforcement learning AI learns through a system of rewards and penalties. They give the example of a robot arm learning to manipulate objects and its application in things like personalized recommendations and improving self-driving cars.
And I can't forget to ask about deep learning, the buzzy term everyone's throwing around.
Of course. Deep learning, which uses those layered neural networks, is definitely highlighted. It's a really powerful type of machine learning that's behind a lot of the recent breakthroughs in AI. It can automatically learn really complex features directly from raw data. Think of things like advanced image recognition or natural language processing. Those rely heavily on deep learning.
But it's not all about machine learning, is it? The guidelines also mention logic and knowledge-based approaches.
You're right. These systems are different. They don't learn from data. They work by using logic and reasoning based on a set of rules and facts that human experts have programmed into them. The guidelines give examples like those classic natural language processing models based on grammar rules and early expert systems for medical diagnosis. The systems that tried to capture the knowledge of doctors.
Okay, so that helps us understand what is generally considered AI. But the guidelines also go out of their way to point out some systems that might look like they have some inferential capabilities, but are actually not considered AI. Can we explore those exceptions? The first category is systems for improving mathematical optimization.
Right. So these systems might use things like machine learning, but in a very specific way. For example, they might approximate functions or parameters to help solve optimization problems faster. But the guidelines say that this doesn't go beyond basic data processing. And one way they distinguish this is by looking at how long the system has been in use. If it's been around for a while, it's less likely to be considered true AI. They give examples like physics-based systems using machine learning to speed up simulations, or satellite telecommunication systems optimizing bandwidth allocation. The key point is that these systems are mainly focused on improving efficiency, not changing the underlying decision-making models in some kind of intelligent way. So even if a system uses machine learning, if its purpose is simply to speed up calculations, it's not considered AI. That feels like an important distinction.
It definitely helps us understand the EU's thinking here. So it's about making existing optimization techniques faster or smoother, not creating completely new ways to solve problems based on learned patterns. Okay, what about the next category? Basic data processing.
Ah, yes. This one covers systems that just follow clear, explicit instructions without any learning, reasoning, or modeling involved. Think of database systems that sort or filter data, standard spreadsheet software without any AI features, or tools that just calculate a simple average. It also includes systems that are solely used for describing data, testing hypotheses, or visualizing data, like those sales report dashboards or opinion poll analyses that just present the numbers without making any predictions or recommendations.
So if it's mainly about presenting or organizing data in a fixed way, it's generally not AI. Got it. What about systems based on classical heuristics?
These systems are all about using rules of thumb and experience-based methods to solve problems. They don't learn from data. The classic example is a chess program that uses a minimax algorithm and some heuristics to decide the best move. These systems can be quite effective in their specific areas, but they lack the flexibility and adaptability of AI systems that can learn and generalize from experience.
And finally, the guidelines mention simple prediction systems. This one seems a bit trickier to define.
It does. The guidelines explain that even some systems that use basic statistical learning rules might not be considered AI if the performance could be achieved through very straightforward means. They give examples like predicting stock prices using historical averages, predicting the temperature based on the average for the past week, or estimating things like customer support response time based on past data. These methods basically establish a baseline but don't involve the sophisticated modeling that we see in more complex AI systems. So it's about differentiating between just identifying simple correlations and building more intricate models that can handle complex, changing situations. But if a system is using even a basic statistical learning rule to predict something, wouldn't that still be a form of inference, even if it's simple? I'm wondering where exactly they draw the line. It's a great question. The key is in the complexity and level of abstraction. Simple prediction systems usually rely on obvious patterns and well-known statistical relationships. They're essentially just extrapolating from averages or basic correlations. True AI inference, as the guidelines define it, involves a much greater ability to discover hidden relationships, create more complex models of the data, and adapt to changing patterns in a more sophisticated way.
Okay, that makes the distinction much clearer. It's about moving beyond simple correlation to a deeper understanding and prediction. Now let's talk about element number 6. The system generates outputs, such as predictions, content, recommendations, or decisions. These are the tangible results of that inference process.
Exactly. These are the four broad categories of outputs that AI systems typically produce. And as the guidelines point out, these categories often require different levels of human involvement.
Let's run through them quickly, starting with predictions. That seems pretty self-explanatory, estimations about future or unknown values. But the guidelines highlight a particular aspect of AI's predictive abilities.
Right. They focus on AI's ability to find complex patterns in huge data sets and make accurate predictions in really dynamic and complicated situations. Things like self-driving cars, navigating traffic, or forecasting energy consumption. This goes way beyond what non-AI systems that rely on historical data or fixed rules can do.
Next, we have content. That's all about generating new material. This seems super relevant with the rise of generative AI technologies like ChatGPT, DLE, all those.
Absolutely. It covers creating things like text, images, videos, music, basically any form of media. Technically, you could argue that generating content is just a series of predictions or decisions, but the guidelines list it separately because it's become such a prominent aspect of AI with technologies like large language models.
Then there are recommendations. These are suggestions given to users based on their data or behavior. What's the difference between AI-powered recommendations and those older rule-based ones?
AI-powered recommendation systems have a few major advantages. They can analyze enormous amounts of data, adapt to user behavior in real time, provide really personalized suggestions, and scale up to handle huge numbers of users. Those older non-AI systems often rely on fixed sets of rules and limited data, so their recommendations are much less dynamic and less tailored to individual preferences. It's also important to remember that some recommendations, like those for job candidates, might still need a human to make the final decision.
And lastly, we have decisions. This seems to imply an output that directly leads to an action without any further human intervention.
Exactly. Decisions are conclusions or choices made by the system itself, essentially automating human judgment in a particular context. The system produces a real-world outcome without a human needing to step in at that point.
So across all these output types, it seems like the key difference is AI's ability to process huge amounts of complex information and generate much more nuanced and adaptable results than non-AI systems.
That's it. And that leads us nicely to our seventh and final element, the idea that these outputs can influence physical or virtual environments. This highlights that AI systems aren't just theoretical algorithms, they have a real impact on the world around us.
So it's about the actual consequences of these outputs in the real world.
Exactly. The guidelines stress that AI systems aren't passive. They have a tangible effect on their surroundings. It could be a physical impact, like a robot arm on a factory floor, or a virtual one, like influencing online platforms, data flows, or software ecosystems.
Okay, so we've now covered all 7 elements. Let's recap. Machine-based, varying levels of autonomy, potential for adaptiveness, explicit or implicit objectives, inferring how to generate outputs like predictions, content, recommendations, or decisions, and the ability to influence physical or virtual environments. That's a pretty comprehensive definition.
It certainly is. And as the guidelines point out, figuring out whether a specific system is an AI system requires carefully evaluating its design and functions against all 7 of these elements. There's no easy checklist or a definitive list of what is and isn't AI. It requires some thought and analysis.
And it's so important to remember that just because something is considered an AI system under the Act doesn't necessarily mean it's subject to the strictest regulations.
You're absolutely right. The AI Act is designed around a risk-based approach. Only those systems that pose the highest risks to fundamental rights and safety are subject to the Act's prohibitions on certain practices, the regulations for high-risk AI systems, and those specific transparency requirements. Most AI systems, even if they meet this broad definition, won't be subject to those more demanding rules.
That's a crucial point to remember. It's not like this is some overly broad regulation that captures every bit of software with a little bit of automation in it.
Exactly. And just to be clear, the guidelines specifically state that they don't cover the details of general-purpose AI models. Those are dealt with separately in Chapter 5 of the AI Act. That's a whole other deep dive for another time.
Well, there you have it. You, our listeners, have just completed a deep dive into the EU's definition of an AI system. We've broken down those 7 key elements and hopefully given you a solid understanding of this important piece of legislation.
To quickly recap those 7 elements, we're looking at systems that are machine-based, operate with varying levels of autonomy, have the potential to adapt, pursue goals, use inference to generate outputs like predictions or content, and those outputs can impact the real world.
So here's a thought to ponder as you go about your day. What technologies do you interact with that you might now consider AI, and what are the wider implications of this definition, even for systems that aren't heavily regulated? It really gets you thinking differently about the tech that surrounds us.
It certainly does. And if you're interested in exploring this further, we definitely recommend checking out the full text of the EU AI Act and the resources on the European Commission's website.
The world of AI is constantly changing, and understanding these fundamental definitions is going to become even more important as we move forward. Thanks for joining us on this deep dive.